Hello guys and welcome. So sometimes we have to provide notches to beams, posts, girders, joists, whatnot. We have to provide a notch. And we have to find out what happens to the beam, the strength of the beam when you provide a notch. And so for this video I'll be providing an example of what happens to the shear capacity of a 2x12 when a notch is provided. So let's get going. So determine if a 2x12 beam with notch supports is adequate, considering shear only, to support 1,500 pounds of shear. The notches are 2-inch deep and long enough to provide adequate bearing length at supports. The depth of the notch allows the remaining depth of the member to be compatible with a 2x10 joist supported on the same level of the structure. So here we have what it looks like. We have our plywood. I forgot to put the rim joist. That's my fault. It's 2x12s, two by 12s, depth of 11.25 inch, and we're notching the two by 12s by 2 inches. We'll be using the NDS, that National Design Specification for Wood Construction, the 2015 edition. And this is again ASD method. I like to use ASD method. I think it's just faster. That's my opinion compared to the LRFD. We'll also be using the NDS supplement to get the design values for wood. We'll be using SPF number 2, and we'll also be using the manual. So if you go to the manual of the NDS, if you go to table M4.3-1, you'll find this table here, and it gives you the allowable stress design. And this here is for the ASD, here is for LRFD. Now for ASD, we're interested for the shear value, FV. So FV equals to FV times the duration factor times the temperature factor times the incision factor. So I'm assuming there is just dead and live, so there's no snow, it's not during construction, the load is just normal loading, dead and live. So this is going to be 1. We have normal temperatures as well, so CT is also going to be 1. And for the incision, the incision, there's none. It's not being pressure treated, so it's also 1. So in the end, if you go and we find the value FV, and I'll tell you where to find it, it's just going to be 1 times 1 times 1 times the FV value. Now, where do we find that? Because this is just a 2x10 member or two 2x10s. If you go to the NDS supplement, table 4A, if you go to where it says spruce, pine, fir, south, I'm looking at number 2. It doesn't matter actually when it comes to shear parallel to grain. It's the same if it's select structural or number 1 or number 2. The shear parallel to grain value is 135 pounds square inch. So that's the value, and everything here that the duration factor, temperature, and the incision factor is all 1. So in the end, the shear parallel to grain remains the same, 135 pounds square inch. So that's good. We need that. Now that we have that, you want to go again to the NDS, not the supplement, not the manual, but the regular one. And if you go to 4.4.3, it talks about notches, and it gives you a nice, and the NDS gives you a nice graphic here. It shows you the notch limitation for saw lumber beams. So the depth that we have here, D, is 11.25, and what they say the limitation for the end notch is that the end notch depth has to be equal to or greater than 3/4 of an inch. Now it's kind of hard to see, but it's 3/4 of an inch of the depth of the original depth of the beam, girder, or joist. So in this case, our depth is 11.25 inches. We multiply that by 3/4, and we get 8.43. 11.25, the original depth minus the notch depth gives you 2.82 inches. So we're notching 2 inches off, and the most we could notch by code here is 2.82 inches. So we're less than 2.82 inches, so we're good, we're okay. All right, so that's perfect. Now, if you go to 3.2.3, also talks more about notches and what's going on, and then talks about what happens to the stiffness of the bending member. We go here, we read here. It says there's an equation. It says for bending members with rectangular cross section, which we do have, and not at the tension face. So that tension face will be at the bottom part of the beam if this is a simple span, and I'm assuming it's a simple span beam and is uniformly distributed. So the bottom of the beam will be in tension. We could use this equation right here, and the equation just says shear equals to 2/3 times the uh, shear stress, adjusted shear stress, times the area of the wooden member, times the ratio of the notch depth over the original depth squared. And here it just tells you what things are. So you could just read that and you understand where things go. So in the end, you just plug in and chug it out. And I wrote here, what do we have? So the original depth of the depth of the member is 11.25 inches. The depth that is being notched is 9.25 inches. That's the end. And then the adjusted shear design value parallel to grain is 135 psi. So we have everything that we need in order to get the allowable shear capacity of the 2x12 that's being notched. So you just plug and chug. You put everything into this equation 3.4-3. So we have 2/3 times FV, which is 135 psi, times the area. Now it's 2x12. So the width of it is going to be 3 inches. The depth, DN, where it's being notched, is 9.25 inches. When you multiply all these numbers here, you're going to get 2,497.5 pounds. Now here for the ratio, the 9.25 divided by 11.25 squared, well, the 9.25 divided by 11.25 is going to give you 0.822. And if you square that, it's going to give you like around 0.6 around there. I didn't write it down. But in the end, the end result is that we have the allowable shear capacity of the notched beam, which is 1,688.4 pounds. And the shear that it's seeing is 1,500 pounds. So because the allowable shear is greater than what it sees, then it's perfect. So we could notch the 2x12, and it's going to have enough shear strength for the anticipated loads that it's going to see. So hope you guys like this example. I think it's a pretty cool example, and I think it's good to understand what happens because sometimes we have to notch members. So yeah, if you like it, please subscribe. If you want to support me, like my videos, and if you have any questions or if you're not understanding some of the things that I said during this video, then just let me know and I'll try to comment back as soon as possible. Thank you and have a great day. Bye bye.